You going?
Yep.
Okay, cool. So guys, the proof was, max of f of n of g of n equals theta of f of n plus g of n. So I broke this up into two cases. So we have, or not like two proofs kind of. So first I proved that it belonged to the big O notation, or the set of big O, and then I also did omega of big omega, the set omega. So what we have is, I suppose that max of f of n of g of n equals f of n, because this right here, we're just picking the bigger function. And then f of n is in set O of f of n plus g of n if there exists a c n naught greater than 0, such that f of n is greater than or equal to c f of n of g of n, which is true. So f of n is in O of f of n plus g of n. Interchange f of n and g of n to get the same result. Now our c needs to be greater than 1. I should have added that in, so let me add that in real quickly. Choose c greater than 1, because if c is less than 1, then this isn't necessarily true. So now we move on. We have, suppose max of f of n of g of n equals f of n, then f of n is in set omega of f of n plus g of n if there exists a c n of naught and naught greater than 0, such that f of n is greater than or equal to c f of n plus g of n. We rearrange this equation, getting this equation. We move on to this equation. So as long as c is less than 1 minus g of n over f of n, then c plus g of n over f of n is greater than 1. And we know that g of n of f of n is less than 1 because f of n is the larger function. So this right here will have to be less than 1. So we add the c and we make sure the c is less than 1 minus g of n of f of n. And then we get this statement to be true. So max of f of n g of n is in omega of g of n plus f of n. Interchange f of n and g of n to get the same result. If you guys could see, I would like to really know your response to see if you think this is the right approach. Thank you.